Hello, everyone. Welcome to this presentation. This is Hunter. Today, I'm going to give you a presentation about what is recommendation system. Okay, so first, let's review the agenda. So we'll talk about what is a recommendation system. And then we're going to talk about the most important part of this presentation, recommendation algorithms. And then we'll talk about how to evaluate a recommendation system. And then we will talk about a very important issue of recommendation system, which is the cold start issue. And last but not least, we can talk about what is a streaming service, how to make real-time recommendations. All right, so let's get started with the first question here. What is a recommendation system? If you go to Wikipedia and then you search for recommendation system, you will get this answer. A subclass of information filtering system that seeks to predict the rating or preference a user will give to an item. Okay, so based on this definition, what do you read? The first thing I read from here is this word, filtering. So now you can see a recommendation system is a filtering system, which means it is trying to filter from a bunch of information to just some information. So recommendation system is not to create some new items or new contents and then recommend that to someone. It is opposite. We try to go to a big pool, and then from there, we filter something that could be preference or could be interested by a user. So it is, we try to reduce from a large amount of information to just a small amount of information. Okay, so that's the first thing. Second thing here is this rating. So we try to understand the rating of an item. So we don't have to say rating, we can say a score here, right? So we try to score everything in that system. So let's say in that system has 100 items. By scoring them, then we understand, okay, there's some item has a higher score, some has a lower score. In that case, we can filter out those lower score items. And then for the higher score items, we recommend to a user or recommend to some people. So that is the purpose for recommendation system. So recommendation system has a lot of use cases. It has been implemented in many very successful companies. The one you probably know very well is Netflix, right? So Netflix is famous for its recommendations. It recommends movies, and believe it or not, 80% of all the contents are people watch are recommended by their recommendation system. And if you go to Amazon sells books at the very beginning. Now it sells everything, right? But only by recommending books, Amazon make 98 billion a year. So that's a lot. Okay. And then Facebook recommend friends. So based on your behavior and other people's behavior, identify, okay, those people could be your friends. In that case, Facebook become the biggest social network in the world. Okay, and then just one thing very important I would like to point out is sometimes when people know, okay, your team's building recommendation systems, so can you help me build something similar but not recommendations, right? And when they ask this question, they actually don't know what is recommendations. So you as a data scientist, you will be here to educate them. Okay, this is not what we are building here. For example, we don't make price suggestions. We don't suggest price for some new products. Those are something other data scientist team will work on. It's not a recommendation system doing. And then we don't suggest names, right? So when people create a new store on the e-commerce website, they don't know how to name that store. But we are not people who come here to recommend something new, right? So we are filtering things. We don't recommend new things, like recommend a new name to you. No, we don't do that. Also, for search terms, sometimes when you type in a search word, there is an auto completion. So it looks like it's very similar to like, I suggest you to search for something, but it is not. It is a auto completion. It is not a recommendation system. But if people search for, after they search for something based on the search history, we recommend some other search terms, or we recommend some products, items, that is a recommendation system. Okay, so try to understand the boundary between recommendation system and other machine learning problems. Okay, cool. So let's move on. Here's one thing I would like to introduce. Recommendation system is very similar to other machine learning systems. So it has not just one sort of machine learning algorithm that can solve the problem. It needs to be run your machine learning algorithms on some infrastructure. So here I would like to make this a metaphor here. Our infrastructure, for example, data pipeline, cluster, Spark, and for example, Airflow to do the model scheduling, and then APIs, all those things are your infrastructure, and they are like a gun. And your recommendation algorithms are bullets, right? So the gun here is try to fire the bullets so that we can hit the target. Without a gun, your bullet is useless. Without a bullet, your gun is firing nothing, right? So both of those are important to us. But today I'm gonna focus on recommendation algorithms. If you're interested in the infrastructure, you probably can do some research by yourself, or we can have an offline call about this. Yep, but just be very clear, those are important, and you need an engineering team to support this infrastructure. All right, so let's go to the interesting part. Recommendation algorithms. There are 4 types algorithms I would like to introduce today. Actually, I break them down into this 5 types actually. Yeah, 5 types. Rule-based, statistic-based, memory-based, model-based, and some advanced machine learning algorithms. Yeah, and then I'll go to them one by one. So first, let's talk about rule-based. Rule-based here means we don't do machine learning. We just do something very simple. For example, popularity. This is when you go to an e-commerce website, you see there's some bestsellers. Or if you go to, for example, YouTube, you see like there's this mostly viewed, right? Those are recommending some products based on the transaction or clicks. Yes, so which means they have been clicked or purchased the most. So they are the most popular products. I would like to recommend it to those to you because other people like it. So probably you also like it, right? They are the most popular things here. And also we can recommend based on revenue. So this is also similar. So which one, whatever has the highest revenue, help my company earn the highest revenue, this product, I would like to recommend that to you because that can bring more revenue to the company. That's from the company's perspective. We would like to recommend something to our customers so the company can make more money. In upcoming products, which is something in the future. So the status here is unavailable. So we sort by the available time, which is the next available products will be in the first place, and the second place, so on and so forth. New arrival, it is similar, but this is something already available. So based on the available time, let's also like give the first one, the first latest available product, and then the second one, third one, so on and so forth. Yeah, as you can see, those are some very naive logic here that we can make some quick recommendations, but don't underestimate the value of those recommendations. They are very, very important, especially at the beginning phase, right? So a lot of people, they really like to see what other people looks, what other people purchased. So popularity is something. When I watch, for example, if I go to YouTube, I watch a lot of videos. I try to watch something new. So I like to go to popularity to see what other people, what's the most popular thing. I want to follow the new trend, the trend other people are following. So those are very important. And upcoming, I want to try something new, right? New arrivals, the same. Yeah, so those are low-hanging fruits for some companies. We can make those easy recommendations, and then they also can help out people to find out like what they like. Yeah, that make those recommendations make a lot of money in recommendation systems. All right. And then the second type is I call it statistics based. So yeah, that means we use some statistics of a product, and then based on that to make recommendations. The first one I'd like to introduce here, it is called association rule. So this one has been used a lot on the e-commerce company. So if you go to Amazon, you search for something, you will see there's a recommendation called like a purchase together or purchase in bundle. For example, like bread and milk. Those two are most of the time they has been purchased together, right? And then yeah, milk and diaper, because yeah, you have a kid, so yeah, those two purchased together. So they are frequently item sets. Yeah, and the association rule is the algorithms to identify those association between products. So here are some packages that you can look into them. They provide this association rule algorithm. For example, this a priori, and on Spark we have this PF growth. In association rule for this algorithm, there's something, some terms I'd like to introduce here. The first one is called support. So support is like the two things that has been purchased, the one thing that, or two things that was purchased, and then divided by the total times of the transaction. For example, here, the supports of Apple is 50% because there are 8 total transactions, and n equals to A. Apple transaction are 4, so 4 divided by A, 50%. Okay. This support means like among all the transactions, how many, what's the ratio people purchase these products, or some products. For example, here we can also calculate the support for apple and beer, which is 3 divided A by A, so that's like 37.5%, something like that. Yeah. And then for the next term, confidence, that means we use one product support divided by another support. For example, we're saying the confidence when people purchase an apple, they also purchase a beer. So we use the support apple and beer divided by apple. which is 3 divided by 4, that's 75%. So the confidence is high, which means most of the time people purchase an apple, they also purchase beer. And then lift is the most important term here. So lift actually decide the association from one product to another product, which means when people purchase apple, they will purchase beer. So that's the support divided by support apple multiplied by support beer. So in this case, it's 100%. So as you can see, when people purchase, so 100% here actually means they have no association, because you can see here, when people purchase apple, they don't have no. Yeah, sometimes when people purchase apple, they purchase beer. Sometimes people they don't purchase apple, they also purchase beer. So apple not necessarily cause people to purchase beer. That means they don't have very strong association here. So when this value greater than 1, greater than 100%, means they have a strong association. And then we use support, confidence, and lift as hyperparameters to turn this model so that we can identify for something that has over the minimum support, minimum confidence, and minimum lift. Those are strongly associated with each other. Then we recommend them based on the results. Yeah. So so today we don't have enough time to go to too much detail. So if you have more, if you are interested in this model, you can go to the website, do some research by yourself. But here, just give an idea. We try to identify the association between a couple of items, most likely between 2 items. And then if we identify that, we can recommend like, hey, you probably want to purchase them together. For example, when you purchase a bread, you want to purchase this milk together. Okay. All right, the next statistics-based model is we call it buy again. So this one type of recommendation. And then under this type, we have a couple of algorithms. Those are first published by the Amazon. So they recommend this 3 algorithms here. One is the repeat customer probability, right? So buy again means, for example, if you buy a toothpaste, you use it like you use it up in every 3 months, right? So after 3 months, you will probably buy this toothpaste again. In that case, in this algorithm, we identify like people who bought product A more than once divided by customers who bought the product A at least once. Okay, that means for all the people who purchase A, how many of them purchase more than once? So that means this is something frequently purchased multiple times, which means people come back to buy again. And this RCP doesn't give a very good performance. So most of the time we use this as a threshold to filter out something like never purchase again by or has a very low purchase again rate. Yeah. So the more important one is this ATD and this MPG model. So what is ATD? Aggregate time distribution. That is we try to like plot the distribution of the purchase frequency, purchase time intervals between 2 purchases. Yeah, this is the right way to say it. All right, so here you can see like some people purchase it at day 1, some people purchase it again at day 50, some people at day 100. Right, based on all the statistics, we plot this distribution and then we fit a log normal distribution. And then based on this log normal distribution, right, so we identify what's this user's login time and his or her last purchase time. For example, for user A, last purchase was December 30, and the login time is 2020 January 1st, which is just 2 days later. So it has a very low probability they will buy it again. So for those users, yeah, no recommend. But for this one, who logging, whose last purchase was like November 20, which is like a month ago. So it's really close to the peak. So it has a very high score here. In that case, we recommend this product. Yeah, so this is the ATD model, how it works. Now, what is modified person gamma model? So as you can see, distribution is based on all the products, all the users on this product. So it doesn't distinguish. So for example, user A probably are someone who always purchases it again at here. User B may be someone who always purchases it at here. That means for different users, this distribution can be varied. So this modified person gamma distribution fits a gamma distribution, and then modify the distribution based on each user's purchase history. In that case, we somehow customize the distribution for each user. Yeah. In theory, this MPG model should have better performance than ATD model. But in the paper published by the Amazon, they found out that these two algorithms has very similar performance. So yeah, it is. So we probably don't need to worry like which one to use. They are like equally good. So yeah, you can just pick one that gives you a better performance. And yeah, they both are better than RCP. So we normally don't use RCP. We only use it as a threshold, like I mentioned at the beginning. Okay, so that's the second algorithm I have to introduce here. And then there are two more here. One is called seasonal topics. So this one is trying to recommend some seasonal products. For example, in Christmas, we want to recommend Christmas trees, and in Halloween, we recommend some like Halloween stuff. There's some seasonal TV shows, right? So yeah, always there's some seasonality products we want to recommend. So the seasonal topics, it is quite simple. So just get for example, if you want to use months as a season, so we get a monthly sales or views of one item, and then divided by the total views or sales of the year. Now you can see November has a 60% sales or views. In that case, it is like significantly higher than other months. In that case, this one has a seasonality, very strong seasonality at November. So we should consider it as a November product. So at November, we make this recommendation. Yeah, so we can do this for every single product, and then we compare the seasonality score at each month. So for during that month, we just recommend whatever has the highest percentage on that month. And then there's a second type we call trending now. Trending now is a very interesting model. So sometimes when we're talking about trending now, that could be some trending products that based on the current trend. The current trend can based on different things. For example, if you have some external data, for example, you're looking to the news, like you probably can identify something are very popular in the news, in recent news. In that case, you recommend those things, right? And also you can based on the sales to identify the trending products. So this algorithm is based on the sales or views. So the trend here means what's the let's use sales as an example. What's the sales in this time period? For example, a week, right? In first week, the sales is like let's say it's 1, and then in the second week, we use the second week sales divided by the last week's sales. Then we identify, okay, the sales in second week increased 3 times compared to last week's sales. So it has a increasing trend here. That is the trending we identify here. So this trending can change based on the time period, and then based on the sales. So yeah, so what you try to do is just try to compare the most recent time period and the previous time period to see if most recent in the recent time, do we have an increasing trend for these products, and how strong is that trend? If the trend is very strong, then we make a recommendation. And one thing you want to be very careful is we want to add a threshold to limit products that has a very low sales. So for example, if you only sell 3 items in first week, and then we sell 9 at the second week, right? So that's 3 times higher. So you see, okay, that's an increasing trend, but do you want to recommend these products? Probably not, because it is very, only sells like 9, still very small sales. So you don't want to make that recommendation. Maybe you can use like 1,000 or 10,000 as a threshold. So everything below 10,000 sales, we don't want to consider those. Only those high sales products and it has an increasing trend, then we want to make a recommendation here. Okay, let's jump to another type model, memory based. So memory based is something, we don't do like, it is not like a machine learning, like we do training and then we do forward backward propagation. Yeah, it's not like that. It's like identify the similarity between products or between users. And then based on that, we make recommendations. For example, here we have the transaction history of all the users, like for user 1, what this user purchased, user 2 what purchased, and then so on and so forth. And then based on the transaction, we can find out like how many times when people purchase item 1, they also purchase another item. For example, when people purchase item 1, 5 times, people also purchase item 2, so on and so forth. Yeah, and then based on that, we can calculate a similarity. In that case, you see item 1, item 2, the similarity probably is like a 0.1, and then for other products, there will be a similarity. So the similarity is between like 0 to 1. And then based on that, we can identify for each product, which product has the most similarity. So probably here similarity is not a good term, let's say relevance. Yeah, because they has been purchased together, so they have a very strong relevancy. Yeah, and then how to make a recommendation? So easy. Let's get one user, for example, user N, and then we get all his let's most recent K purchase, and then for this K product, we get let's say maybe top 5 similar items for this K product. So it's a 5K products. And then we group by the user to sum the score for each item. Yeah, in that case, which one has the high score? we'll rank that to the first place, and then so on and so forth, right? So based on that, we can make a recommendation because those are very relevant to users' recent purchase. Okay, and then for the user-to-user similarity, is it similar? Right, based on this transaction, we can get this user-to-user relevance, I would say user-to-user purchase similar products matrix. And then based on that, we get the user-to-user relevancy, right? And then for one user, we get its similar users, right? So for this user one, we get user I, we get his or her similar users, k similar users, and then we get for each user, we get their purchased items, and then we multiply, and then we group by this user, and then for each item, we sum the score, sum the user similarity score. In that case, we also can identify, okay, so because this one has been purchased a lot by a relevant user, so let's make this as a recommendation. So that's the idea for this memory-based model. All right, then let's jump to a very important concept. I would say the most important concept in recommendation, model-based recommendations. The first one, it's a very popular one. We call it content-based filtering. And then there's another one, also very famous, called collaborative filtering. So I will introduce that in the next slide. Here, it is about content-based filtering. So content-based filtering, that means if I purchase something and then I identify some similar products, so I recommend those similar products to this customer. How to identify they are similar? There's one way to do it. It is to get its description or some other features. For example, price, color, brand, category, and description. You can even get its image, and then you convert image, text, features, and everything into build a feature engineering and then get a feature vector and use those vector. You calculate the cosine similarity. Based on the cosine similarity, you can identify which are similar products. So the cosine similarity, it is use these vectors, right? So for each vector, you can calculate a cosine distance, which is this angle here, right? So if two products has a smaller angle, which means they are very similar to each other. So this cosine similarity is a value between -1 to 1. So -1 means they are totally different. 1 means they are exactly the same. Yeah. So if we use the product description as the feature, let's use that as an example here. First, we get the data, and then for each product has a description like ABC or something. Yeah. So first, we probably want to do the cleaning, like remove stop words, remove numbers, or do lemmatization, tokenize, something like that. Yeah, that will be introduced in NLP class, so I will skip those here. And after that, we can do feature engineering for the description. We can use TF-IDF to convert that into a vector, or we can use word embedding to convert that into a vector. And then use this vector, we do the cosine similarity. So for each item pair, we have a similarity. And then for one product, we just get all the products and then sort by similarity. So for this product, we will get those are the most similar products. Yep. So this is a very important recommendation we're going to use a lot because after you get the similarity, you can use that to do a lot of things. For example, in here, item to item similarity, you can use content-based filtering to get a similarity to replace this table. You don't need to use the transaction to get a similarity. And then based on that, you can make a recommendation based on the purchase history to recommend similar things to the purchase history. Okay, let's jump to the next algorithm, which is lots of people think this is the most interesting one in recommendation algorithms, which is the collaborative filtering. So the idea is we identify who are similar to you based on their behavior. So for example, you both read some same articles, and then if the similar user, they also read a new article, I'll recommend that to you. Okay. So for the collaborative filtering, we use there's a matrix called, there's an algorithm called matrix factorization. Oh, by the way, sometimes we also consider item similarity and a user similarity as a collaborative filtering, because this is also try to identify who are the similar users. But those are memory based. I just list them here. The most important one is this one, matrix factorization. So what is matrix factorization? It is a statistic term. So I won't go to too much detail here, but there are two very famous matrix factorization algorithms, ALS, alternative least square, and and SVG. So if you like to use them in the PySpark package, you can find this ALS algorithm. In Surprise, you can find the SVD algorithm. So those are some well-developed packages. You can directly use them and try them. Yeah, and the idea here is first we get the transaction data, or we get the, for example, rating data. Yeah, here we just use transaction data as an example. After we cleaning the data, right? So there's some thing like we don't know how much products has been purchased. So yeah, just remove NA, something like that. And then you get this idea, like for every user, what's the transaction, or like what things they have, what they have purchased, and then what's the quantity they purchased. Now let's convert them into a user to item matrix. That means for this user, if they purchase this item maybe like say 5 times, then it's score as 5, and then for item 2, 4 times. But for this item M, user has never purchased this one before. In that case, what we try to predict here is how likely this user will purchase these products. So the ALS model will predict this value. Now let's base on this value, and then we can sort it all the products for this user, and then identify those are the most has the highest probability that this user will purchase, and then we make that recommendation. So that's a basic idea. I will use this as another example, right? So when user they read some books, they will probably rate the book. For example, this user rates the first book 4 points, and then the second book 3, and then this one 5. So we probably will ask, like, will this user be interested in this book, right? So based on matrix factorization, we try to get a vector for each user based on this sparse matrix. For example, we get a 3-dimension vector for each user, and then a 3-dimension vector for each product. And then if we multiply them together, you will get a value for each cell. So we will receive a new matrix by using user vector and item vector by multiplying them. Then we can get a value for this book. So we know for this user how much he or she will like this book based on the so that's the purpose. That's the how matrix factorization work here. Yeah, so the basic idea is we generate a vector for each user and a vector for each book, and then multiply them, we get this matrix. And then in the matrix, for something they have purchased or have rated before, we ignore them. But those they have never purchased or read before, then we rated them by the score, and then we make recommendations. And then this generating user vectors and item vectors, this concept is very important. We're going to introduce them in the deep learning as well. Okay, so let's jump to deep learning. I believe a lot of people are very exciting when people are talking about deep learning. Yeah, but to me, I would say every single algorithm in recommendations are important. Even the rule-based, which is now not just some very naive algorithm, those are very important. Those make a lot of profits. Yeah, and deep learning, when you try to use it, you need to be very careful. I would say deep learning is like a silver bullet. It's like a black box, but it's very strong. It can solve a lot of problems. So if you have a very, very good data and a very good system, you can use the silver bullet to solve everything. Yeah, but you need to understand, like if you want to use this silver bullet, you need a gun that can fire this bullet, right? So we need a very strong system. Like we need a GPU, we need a very good infrastructure, we need a lot of data, so that this algorithm could run everything by itself and then make the best recommendation. All right, so here I'll go to some quick introduction. I won't go too much details. First of all, when we create a deep learning recommendations, we will do one thing here. It's called user embedding and item embedding. Why? Because if we want to make a recommendation in using deep learning model, the idea is we have for each user, we have a lot of items to recommend. The first step is to reduce that from maybe millions of products to just hundreds, right? So that's the first step. We call it candidate selection, or we call it recall. Yeah, and then after that, after getting these 100 products, then we want to do a ranking. So rank this 100 products. After ranking, we know, okay, this one has the highest score, so we make it into the first place. So in that case, we maybe only want to recommend top 10 products, and then we send that to the front end, so the website users will see the results. Yeah. So why user embedding, item embedding is important here? Because for a user or for an item, we want to use embedding to generate the feature, and then the feature will be in this way. It's like a vector for a user, and then a vector for each item. How to do embedding? One simple way is we can use matrix factorization to generate user vector and item vector. So this is one way to do embedding. There are also some other embedding models you can try. Yeah, like autoencoder or something like that. So yeah, I want to I won't go too much details here. After you getting the vector for each user and item, then we want to do another step here, because for one user, in my this user might interacted with a lot of products, right? So how do we want to put those items vectors together? For example, if a user interacted with 3 items, but another user could probably interacted with 5 items. So we want to get, for example, we can use average embedding to average everything this user recently interacted with. For example, the most recent 5 products, and then we average the embedding vector. So we use that to represent this user's preference, item preferences, right? And then another way is we don't need to average them. We just put them in sequential. So we have a user vector followed by the most recent item vector, and then the second one item vector, and the third one, right? But let's say in that case, if we want to get top 5, but some user only have top 3, in that case we're missing 2 vectors. So we probably, the only way is we can get some like a average value, or we fill in with all zeros. Yeah, and then after doing this feature engineering, we can build this recall model. So this could be a multi-classification model. So because the idea here is we want to recommend maybe like hundreds products out of millions products, right? So this is a multi-classification model. And yeah, and then here you can use the neural networks. Yeah, and there are multiple models you can try, like a CNN, RN, yep. And then after getting these 100 products, we can use the user embedding plus each item embedding as the input, right? So for among these 100 items, we have a this user's vector plus the first item's vector, and then the user vector plus the second item's vector. And then we're gonna do a classification model. The label can be based on the previous behavior data. Could be, for example, this user has purchased this product or not, right? Yeah, based on that, we can like predict a probability of each user item vector. We can predict a probability that is this product gonna be purchased by the user or not. Yeah, and then we rank by the probability, then we get this results here. So that's the idea. So first we use a recall, get the candidates, and then we use a classification model to get to rank those candidates, and then we make the top K as recommendations. Yeah, again, this ranking part can also be a different model. It doesn't have to be a classification model. Depends on how you interpret this question. Okay. All right, now we talk a lot about algorithms, but as in machine learning, you always understand like we need to do the evaluation to identify how good is your algorithm or how good is your model. In that case, we have the confidence to say that we want to implement this model because it is a good model, right? So for recommendation system, evaluation sometimes it is hard because most of the algorithms are unsupervised learning. For example, content-based filtering, it is just give you a similarity score. So how can you tell this is a good similarity score or a bad similarity score, right? If you only use description, you can get one similarity score. If you use, for example, description plus image, you will get another similarity score. So how can you tell which one is better? Which one can better tell you like the similarity between products? Yeah, so that is very hard to measure. But here we still want to introduce you some evaluation metrics that you can use to evaluate the performance of your recommendation algorithms. The first one, is offline evaluation, which means when you're doing the training, you can use this to compare the performance of your recommendations and the actual purchase. That means when you do the training, we probably can use, for example, previous, so in your total data could be like a 1 year data, and then you can use, let's say 10 months in the, the first 10 months in training, and then use the last 2 months as a testing. So the testing will be this actual purchase, which is the last 2 months data, and then or click data, right? And then use the first 10 months, you make recommendations, and then you see how many recommendations has been purchased or clicked in the last 2 months. So precision recall F1 score, that's some basic metrics. I don't want to go into too much detail, and our CAUC curve is score is the same thing. One thing I would like to introduce is this mean average precision. Basically, it is precision, but let's say if we make 10 recommendations, so we want to see what's the precision for these 10 recommendations, and then how many recommendations is also important. So for example, among these 10 recommendations, if I can only display one thing, we probably only display the first recommendation. So what's the precision of the first recommendation? And then we also want to look at what's the precision of first and second recommendation, and then 1, 2, 3 recommendations, and then 1, 2, 3, 4, all the way up to 10, right? So for each sequence, we have a precision, and then we take the average. That's the average precision for one user's recommendation. And then for all the users, we take the mean of their average precision, then we get this MAP. This can give us an idea like how, in general, like how good is your recommendation for all the user, and then for different numbers of recommendations. Another thing, it is called coverage. So this is very straightforward. So coverage means like your recommendations over the total number of items. If you only recommend 100 unique items, but there are like let's say 10,000 items in total, so your coverage is like 1%. So that's probably not a very good coverage. Another metrics is diversity. So that means how diverse your recommendation. It's your recommendation results. One thing we want to get is the similarity. For example, if we had that cosine similarity result before, then we can directly apply here. If you have 10 recommendations, we want to calculate each pair of these 10 recommendations, their similarity. And then -1 could be the difference, right? 1 minus the similarity will be the difference, and then we get an average. Then we can say, okay, for among these 10 recommendations, how good is the diversity? If they have a high, it depends on where you want to make the recommendation. For some place, if you need a high diversity, then you can use these metrics to measure. Novelty is something similar to diversity, but this novelty means like the recommendation versus your purchase history or your click history, right? If in your recommendation, like 90% are new that you have never purchased before, then probably that fits the novelty. Yeah, for some recommendations, we don't want to reevaluate everything. For example, for buy again, novelty doesn't make sense because we ask them to buy something back. So there's no novelty. everything we recommend has to be something they purchased before. Yeah, so yeah, use those metrics wisely. That could be, so that means for different recommendations, we use different metrics. Online evaluation, it is something after your recommendation system go online, you want to use this to see like what's the click-through rate. That means how many recommendations has been clicked by users. If that gets higher, that means yeah, your recommendation, people click your recommendations, people that can somehow lead to their purchase or like or view or seeing watching a movie, right? So that can cause this high conversion rate. If you have a high click-through rate, that can also result in a high conversion rate. Conversion rate means when people make the final purchase. Yeah, and the revenue is similar, like how much revenue related to the recommendation items. All right, so this is a very important issue we like to discuss here, cold start. Cold start means, yeah, when you in winter, when you try to start the engine of your car, you couldn't start because it's too cold outside. Okay, yeah, here the cold means, yeah, we don't have the data to support your algorithm. For example, when there's a new product, we don't know like how many people will purchase these products because there's no purchase data, there's no click data, no any user behavior data on this product. So probably we can use content-based filtering to get its description. Yeah, for new products, the description or the price or some, you know, there's some item related information will still be there. We can use content-based filtering to calculate similarity. And then for a new user, the user has never, you know, done anything on this website before. So one thing is we can look into its demographic data, for example, like gender, age, or geographic information. We use that to identify, we can use that to, for example, do clustering, you know, or maybe we create a user profile and then we do customer segmentation. So for each segmentation, we can identify some, identify those are similar users, and then we recommend something that's, you know, the most popular products in among these users, and then we make that as a recommendation here for new users. The most challenging one is this last scenario, new system. That means no data at all, right? So in that case, one solution is we can try to use some external data or maybe some similar systems. We can get the data from there and then use that to identify, for example, if we make a new social networks. In that case, if we can get your contact information, then we get a phone number there, so that we can probably link the phone your contact information, other people's phone number linked to their accounts, so we can recommend some friends to you. So that's the idea here. All right, cool. We still have some time, so let's quickly review. There's a streaming service. Streaming service, that means real-time data processing service. Yeah, so as you can see, lots of machine learning models in recommendation system. They are like, for example, memory-based, or for example, for content-based filtering, when you calculate the similarity, all the similarity has to be calculated. That's a huge matrix. So for those models, we have to train them offline in batch. That being said, it could take hours or a long time to make the training. You know, after that, we probably will not retrain it, or it is like an offline model. That means after we calculate the similarity between 100 products, right? So the similarity score won't change for maybe like a month, because the description will not change, right? In that case, it is not a real-time thing. But at this moment, if we add a new product, we want to get this new product similarity to other products, but immediately. That's where we want to use this streaming service. So for example, here, if we use, there's some infrastructure like PubSub or Kafka, or we can use CDC to identify the data change in those in your database. So for example, if you store the products information in MongoDB, and then you see there's a new products coming in, so that's a data change. We capture that data change immediately and then send that to Kafka, which is a message queue. So that Kafka will quickly also send that information to your recommendation model on Flink. Flink is a place, a framework that can run streaming model. Another example is Spark streaming. So those are like they can handle like a data in a very quick, give a very quick response, which means we can run the model in milliseconds, and then we return the results to the database or to the API, so that we can give the recommendation. Yeah, so for this new products, on Flink, we can quickly calculate a similarity between it and other products. And then we identify what's the most similar products to this new products. In that case, we can make recommendation for these new products. Yeah, so yeah, for the streaming service, just give you a very quick high-level overview. But again, you can see there are some terminologies like Kafka, database, Flink here. Yeah, those are some engineering terms. So that means for streaming service, we need to build the infrastructure first. So yeah, we need a gun to fire the bullets. And then here, this bullets is like a real-time machine learning model. The algorithms are the same, but we use a different framework to run the algorithm. So the response of your model will be much faster, that can achieve a real-time recommendation. Okay, that's everything I would like to introduce today. Yeah, I spent a lot of time here. Hopefully you will get the idea what is a recommendation system, and then understand some algorithms inside that can be implemented in a recommendation system. And then if you have more interest, if you are interested in some algorithms, I encourage you to read a paper, like what's the source paper of the algorithm. For example, the ATD and the MPG model, there's a open, like a public paper, yeah, open accessible paper from Amazon. If you want to read the deep learning, there are some very good papers about like how YouTube use deep learning, or how Netflix use deep learning to, or how, like Tencent, how they use deep learning to make recommendations. That those papers has very detailed information about the algorithm. And also, I also put some like packages in the slides for some algorithms. If you are interested in those algorithms, try those packages. Yeah, so that's everything I'd like to share today. Hopefully that can be helpful, right? Thank you for listening. Have a good day. Bye.